So yeah, today we will be talking about this one, data visualization and tools. Right. Now, to start with data visualization and tools, obviously we should know about some of the basic things here, right? What is visualization, why it is used. For example, you can check the contents of this particular video, right? Introduction to data visualization. So we will try to talk about what are the basic things, what are the basic types of plots one should be aware about. For example, what bar plot actually tells you about your data, right? Then what is histogram, for example? So it tells about your data. Right? There are different types of plots we can actually plot. For example, something like box and whisker plot we have seen, which we call it as a box plot. Generally, we make use this in pre-processing step. Right. So I'll be talking about data visualization and its importance, and these different types of plots we will try to talk about. So what I will do is maybe as we haven't discussed about something called as Matplotlib. Matplotlib is a package which helps you to plot different types of plots. And one more is there that is called as Seaborn package. So I will just try to go through this package is fast, and I will try to talk about different types of plots which are available. Again, in specifically as we are making use of Python language in these sessions, right? But till now we have used Python only. So specifically talking about Python, you have Matplotlib, Seaborn to plot different types of plots. But again, it is not like that there are these plots only. There is something called there are these packages only which can plot the graphs. There are other packages also. For example, there is something called as cufflinks. Cufflinks is also available, or there is something called as Plotly, right? So these are also packages which are available for plotting different types of graphs and visualization, right? But again, before talking about all those packages, let me just give you a brief idea about what is there in this fourth unit. So you can check challenges to big data visualization. So you should be aware about the term like big data. We'll try to talk about this. We'll try to discuss what is big data, what are the different factors which come into picture when we talk about big data. Okay, techniques of data, the techniques for visual data representation. We'll try to talk about types of data visualization. Anyway, we will be talking about different types of data visualization here itself. Visualizing big data. So how to visualize big data, why it is important to visualize big data, we will talk about that, and tools used in visualization. So as mentioned in your syllabus, they are talking about something called as Tableau. Right, Tableau is really very important tool. Let me just tell you that, see, just to discuss about Tableau is, itself is a big one, right? You will see people only working in Tableau. So in data scientist stream, or data scientists even make use of Tableau kind of a tool, right? So there is Tableau, there is something called as there is a tool of Microsoft. So there's something called as Microsoft's Power BI. So this is also something which we can make use of for data visualization. So Tableau is like a drag and drop tool. What one should know about Tableau is, or what one should know to learn about Tableau is, you should have knowledge about databases. You should have knowledge about database, or some basic things about DBMS, or something like SQL you should be aware of. Basically, joins, I can say, right? Concepts of joins from SQL. So that will be sufficient. That will be more than sufficient to learn about Tableau. Because Tableau, as I told you, it's a drag and drop tool. But yes, it can actually do a number of things, and many people make use of Tableau. So if you suppose understand Tableau, it will not be difficult for you to understand Power BI. And there are different types of data sets from which you can export, and the data from which you can export the data in Tableau, and you can have different types of visualization with the help of Tableau. So yes, I will be showing you some hands-on examples on Tableau also, but let me make a point that, see, whenever we talk about data science, people think that the people who are experienced only they can work in data science team. It's not like that, right? In data science, there can be a Python developer, there can be a Tableau developer. I can say the people who work on Tableau. There can be a machine learning developer, right? So all these roles actually come under data scientist, or all these people can work in data scientist team. Even a person working with Microsoft Excel can also be a part of data scientist team. So this is just to clear the confusion that, okay, you should know, you should have a very high experience, right? You should have 6 to 7 years of experience to work in data science team. It's not like that. See, generally that might be the case, but let me tell you, even for example, as we are going to talk about Tableau, so let me tell you that person who only knows Tableau, who knows Tableau only, right? Even that person also can be a part of data science team. So just make these things clear, right? See, specifically talking about Python, in Python I told you that Matplotlib, Seaborn, Couplings, and Kotlin. These are the packages with the help of which you can go and you can do the data visualization. But again, Tableau is also a tool which can do the same thing. And yes, there are some very good points about Tableau, right? Which one should be aware of if you really want to go for data visualization. You can go and you can do data visualization with the help of Tableau. You can do reporting with the help of Tableau. That's why even if you are not aware about any language, any programming language, but still you can make use of Tableau. And talking about jobs, talking about the salary for the people who make use of Tableau kind of a tool, it's really good, right? People have had some packages who work in Tableau, who have experience in Tableau, right? So let me tell you that Tableau is like you can spend your whole life in Tableau, and you can just spending your whole life in Tableau, you will still will not be able to finish it. We talk about any tool for that matter. You talk about Microsoft Power BI, you talk about Informatica, you talk about SAS, you talk about any tool. All these tools are like that, right? But yes, specifically those people who do not like to program, do not like to code, definitely, and still they want to work in data visualization, in data science, or maybe data analytics, business analytics. Yes, this is a good option actually. Tableau. And yes, even though someone likes coding, if they learn this one, that will be really handy, right? That is definitely going to help because Tableau is very famous for creating something called as dashboards. We will talk about it. What is actually a dashboard? Dashboard is something like you will be able to see graphs. You will be able to see different real time values in the form of reports and graphs at one place. Some of you who might be knowing about the dashboards which are available by YouTube or Facebook, right? So yes, with the help of Tableau, you can create the dashboards. You might have seen some people created dashboards for COVID-19. Or you might have visited some website, and on that website, something like this you must have seen. There is some graph, right? And that graph is showing you all these values. There is something like pie chart here, something like this one you must have come across, something like this. So this kind of a dashboards, which which is going to show you real-time values. That those kind of dashboards can be created with Tableau. So specifically talking about Tableau, I'll be showing you some hands-on examples what you can do with the help of Tableau. I will go and I will try to compare Microsoft Excel. See, what I will do is I will do some tasks with the help of Microsoft Excel, and same task I will show you that you can do with the help of Tableau, but in very less than as compared to Microsoft Excel. I'm not saying that Microsoft Excel is not good. Obviously, it is really good. But when you come to Tableau, you will realize that it takes a very little time and it is easy to do the things with the help of Tableau as drag and drop. You do not require any programming knowledge for that. And what you need is basic knowledge about that particular domain, knowledge of the things like basic concepts like, as I told you, data, database, DBMS, and in SQL you should be aware about joins or maybe some aggregate functions. Right. So whenever I say aggregate functions, so I mean to say all the aggregate functions, right? Some average or mean, we can say max, minimum value, so all these things. So whenever I say aggregate functions, I mean to say group functions. Wherever, so what are the group functions? Group functions are the functions where you have multiple inputs and only one output. That is called as, so these are the inputs, multiple inputs and only one output. That is called as aggregate function or row function, or what you can say multi-layer functions. So there is something called a singular function. Singular function, what happens in that case? One input and one output. That's a singular function. So you should have knowledge of these kind of functions. Which, if you are aware about SQL, you must have come across structured query language. And again, structured query language is like a English language only. It is not at all difficult to understand. That's why I told you that I'm telling you that the people who feel that okay, I'm not good with coding or I do not like coding, right? You can go and you can try to learn Tableau kind of thing, right? So and yeah, let me Let me just tell you, if you really want to understand Tableau, A to Z about Tableau, maybe 2 months will be sufficient, right? So when I also conduct the training for Tableau, complete training in 2 months only we finished everything. Projects from the basic till the projects, till real time projects, we finished everything regarding Tableau. Why am I saying you that? Why am I telling you all this thing? Because see, if you are thinking that okay, I want to work in maybe domains like artificial intelligence plus IoT plus machine learning or deep learning, something like this, data science, right? This is going to be very very handy. And even if you just want to work in visualization or maybe as a data analyst or business analyst, yes, this is going to really help you. Right? Even if you, by chance, suppose if you come across some another tool, but if you know Tableau, you will be able to understand other tools easily. Right? As I mentioned, some of the names like there is something called as Power BI. Power BI is a Microsoft tool, right? Or there is something called as Informatica. Informatica is Informatica. Informatica is actually a company. This is what I am trying to say. It's actually ETL tool. This is nothing but extraction, transformation, and load. But yes, if you have a good idea about this, if you have done some hands-on on this kind of a thing, definitely Power BI kind of a thing will not be difficult. Okay, so yes, when we are finished with when we are done with all the basic things, discussion on the basic things, definitely I will go here. I will show you the installation of Tableau. I will show you how to make use of Tableau for free. And let me tell you, Tableau is actually free for 1 year. For students, if suppose in your university, you must be having your email ID, right? That is ending with the domain of your domain name of your university. You just need to fill up some details, and you will be able to make use of all the features of Tableau for free for 1 year, right? But I will tell you after 1 year also how to make use of Tableau for free. I will be talking about all those tricks, right? When once we start with the installation of Tableau. And installing Tableau, again, it's easy thing actually. It's not going to require that much time. In my case, if I want to show you, I think it is there. Just check it. Yeah, see. Once it is installed, you will be able to see this kind of icon. I hope you are able to see this. Right? Something like this here or here. In my case, there are different versions of Tableau which I have installed. So you can check it. On desktop, this kind of icon will be created. That is the input table. You just need to click on that and you'll be able to see the user interface of that. So I meant to say it's a drag and drop tool. Anyone can learn it. Even I will go further and I will say that even a person from a non-engineering background, right, he or she also can understand that and can get a job, which is a very good package actually. Okay, so yes, it's really good that they have mentioned this particular tool in your syllabus. I will go and I will try to show you hands-on at the end. Now, to start with this data visualization, right? Let's try to discuss about the terms like what's big data. So as they are talking about data visualization, what is data? We have already seen, right? We already talked about that. So let me just make some points clear here. So as we want to know what is data visualization, data visualization and tools. This is what we want to discuss today. So before going and doing some hands-on things on Tableau, let me try to discuss some basics. So if you remember, when we started with these data science sessions, we started our discussion with very basic term, right? We started with data, and we have seen that data is nothing but just a raw material. Data is just a raw material. Then we move to the next point, and that is nothing but information. So I told you, what is information? Information is the processed data, right? This is what we talk about. Information is processed data. Data is a raw material. So this is what we have seen. And after that, we talked about some terms like what is database. So at that time, I told you that database is nothing but what? Database is a collection of related data. The term related, I told you, is very, very important. Collection of related data is nothing but database. So there are different types of database. Even I say that text file is also a database. Microsoft Excel database, MySQL database, Oracle database, Google database, right? So collection of related data is nothing but database. And then we move to the next point, and then we talked about something called as database. So I told you that database is sorry, not database, and to say DBMS, not database actually, DBMS. So I told you that DBMS is just a software. Database management system is a software. which you can make use of on top of your operating system to talk with the database. Right? And yes, there is something called as RDBMS. So R in this RDBMS stands for relational. And I told you, relation in database terminology always means table. That means relational database management system is nothing but what? It's a DBMS, it's a database management system which deals with tabular data, right? So MySQL makes use of RDBMS, right? And once we discuss these things, we have even discussed about types of data. So I mean to say, we talked about something called as structured data, if you remember, right? Structured data, I told you that structured data is nothing but the data which is stored in the form of rows and columns. So tabular data is the example of structured data, where you have rows and columns. Then we talked about something called as semi-structured data. Right. Now, what is semi-structured data? Semi-structured data, the best example of semi-structured data is XML database. So here, I have given an example XML or HTML database. For example, right, HTML code if you look out, right? So, if you remember this, something like this, Angular bracket reflex is on. I want to store the name. So what do you have? You have data as well as the code. That is good semi-structured data. Then we talked about something called as quasi-structured data. What is quasi-structured data? So for this quasi-structured data, we discussed the example of clickstream data, right? If you remember, clickstream data is the example of quasi-structured data. Now what is clickstream data? So for example, if you go and if you try to search something, if you Google something, suppose if you Google pudding, now you will be able to see a lot of results related to pudding. Suppose if you click on first result, there will be a change in the address bar. If you go on the next page, if you click on the link, one more link, again there will be a change in the address bar. Right? So whatever the data which is being generated in the address bar, that's an example of clickstream data, or I can say quasi-structured data. And finally, we talked about something called as unstructured data. So there, all the remaining data, right? Whatever we talked about, that it is going to come under unstructured data. Right? So we already talked about all these things like video, audio data is an example of unstructured data, or Facebook data, LinkedIn data, Twitter data, Instagram, or for that matter, in general, social media data, email, SMS. All these are the examples of unstructured data, right? So as per your syllabus, they have mentioned that they mentioned a point that visualization of big data, right? So obviously, before going to this particular term, big data, right? If you go and if you try to search, there are a lot of definitions related to this particular term, that is big data. But yes, big data. Out of this data, is it's clear actually. We have seen different types of data. Now talking about this big data, I think this also we have discussed. But just to revise the things, let me tell you that whenever you talk about big data revolves around five V's. Right? Remember, big data revolves around five V's. Now, which are those five V's? Earlier, actually, it was three V's. Later on, they have made some changes in the definition, and now it is five V's. So, which are those five V's? The first V is volume, right? Volume. Then the next one is velocity. So, the data which is going to have all these features, right? As per the conditions, volume, velocity, then variety, right? And then value, and then one more we have it is varsity. So big data actually revolves around these five V's: volume, velocity, variety, varsity, and value. Now I told you that volume is nothing but what volume talks about the size of the data, right? Now big data, if you just try to concentrate here, big data, the term itself tells you the data which is very big is called as big data. But the question is how much big? So this volume is going to come into picture. So generally it is in petabytes, right? 10 is to power 21 0 petabytes I can say, that much big, right? So the volume talks about the size of the data which is very big in size, that can come under big data. Velocity is what? Velocity is nothing but the speed, right? The speed with which the data comes and it goes. Data comes from source and it, or maybe from source to destination, I can say it travels. That is nothing but the velocity. So if you remember, I think I give you an example for this one, right? Velocity whenever we say, so the best example here is sensor data, right? You might be knowing about driverless cars, right? Companies like Google, Microsoft already working in those projects which are related to reinforcement learning, right? So robots or examples like driverless cars. So In driverless cars, for example, they are going to need lot of sensors. Right now, also you can see that in the cars which are available right now, in those cars also you will see that there are a lot of sensors. So in that case, what happens is many times it is required that you need to send or receive real-time data. But in that case, the data should be received with very high speed, and that's where this velocity is going to come to picture. So that kind of a data is also going to come under this big data. The data is having high velocity. That is nothing but the speed with which the data travels from the source to destination and vice versa. So this speed actually talks about that. This velocity actually talks about that. Variety is nothing but what? Variety is nothing but different types of data, different varieties of data. It may be structured, unstructured, quasi-structured, or semi-structured. Right? For example, just take example like it may be audio data, video data. It may be suppose sensor data even. It may be variety of that. So sources can be a tabular data. See, suppose data might be coming from Excel file. This is the Excel file. This is one source. Data might come from some text file. Data might be coming from some database like MySQL. Data might be coming from some database like MongoDB, and so on. Sources can be anything. Right? Even data can be coming from some API, right? Application programming interface like Twitter, Facebook, YouTube, LinkedIn. So data might be coming from different sources, right? Related to the same domain. So what we need to do is we need to keep that particular data at one place and then go and process it and then do the visualization and all. So obviously, to do the visualization, definitely everything should be at one place. So sources or varieties of data is possible. So this variety actually talks about different levels, different types of data. Value is nothing but what? Now see, you have data, right? Now, even though you have data, is that data going to generate some value in terms of quality, value in terms of money, the money which you will get, or value in terms of profit, I can say. Is it generating any profit? Is it creating any value? Yes or no? It should create, right? It should create. There will be, it should be, it should, what we can say is, it will be very useful. Otherwise, what is the use of fetching this much of data, this much of big data, right? And varsity is nothing but what? Varsity is nothing but the trustworthiness. So what do you mean by this? It means the source from which the data is actually fetched. That source should be trustworthy. At least that source should be something like you should rely on that source for getting some data from the source. It is not like that that data should be something fake. It should be reliable. It should be trustworthy. If it is trustworthy, then only it is going to create some value, right? Then only it is going to get some profit. Then only it is going to be helpful for creating, for improving the service, for creating, for improving the quality of the product, and so on. So all these B actually are part of the term big data. So remember, volume, velocity, variety, value, and varsity. So in your exam, there can be a question. Okay, which are the five V's? Which are they? So remember at least the names: volume, velocity, variety, varsity, and value. These are the five V's. Now, so I hope everyone is clear about what is the concept of big data. Now, if you go and if you try to check your syllabus, challenges to data visualization, right? So for this, as I told you, in Python itself, you might have come across different types of plots. So let me show you some of the plots. So I think we discussed about NumPy, we discussed about pandas. Let me go and let me try to show you some of the plots in case of Matplotlib. Matplotlib is actually a library. It's a package. You can see it's package available in Python, but it is Matplotlib is it has taken the reference from tool, one of the tools which we call it as Matlab, right? So if your people are knowing about Matlab, Matplotlib is actually a library which can do everything what Matlab can do. You can see Matplotlib is the grandfather library of data visualization with Python. So whenever we talk about data visualization, as per your syllabus, as the first last unit itself is about data visualization. So as we already talked about Python, right? So just in reference to that, whenever we talk about data visualization and Python is there, Matplotlib is going to come into picture, right? So this person has created a Matplotlib library actually. So he created it to replicate this one. Matlab. Matlab is a tool. Okay, it's a tool actually, which is available. And just to replicate that, just to replicate all the activities, all the tasks, what Matlab can do, Matplotlib was created. Okay, so if you want to go and if you want to try out different plots, definitely you can try out all the plots. What I will do is I will just try to send you a link in the chat box, which is a official page of Matplotlib. Just check into chat box, you'll be able to see that. Maybe those who are aware about it, you can try out plotting the plots. Okay, so here I can see. Let me show you at least some of the plots which you can plot here. But remember, whatever the visualization you will be doing with the help of Python language, you are going to require Matplotlib. Suppose let me import Matplotlib. So import. See, in my case, I will be able to import it because it's already there. It's already installed. Import matplotlib.py plot. This is what we do. Py plot as plt. This is just a alias. That plt is just a alias. Another name for matplotlib.py plot. Now here, what you can do is plt dot, and then you will be able to see a lot of methods for data visualization. Some of these methods we will try to make use of. For example, you can say hist is there, hist2d is there, hlines is there, hsv is there, and so one by one we will try to talk about. But yes, obviously there are a lot of methods which are available here. It's not possible to go with all the methods. So as I sent you this particular link, right, this one. So if you go and if you have your computer open, you can try out all these things. See what happens in case of Matplotlib team. You don't have to remember anything. Everything they have given, whatever is required, everything they have given on the official page of Matplotlib. Even the code also they have given. For example, here if I go and if I try to click on documentation or example format, here click on examples, you'll be able to see different types of visualizations here, right? So you can check it. All these types of graphs you can plot in Python and many more, right? Even 3D, 2D graphs you can plot, even images and contours and fields, right? So whatever may be the domain, you can actually go and you can do the visualization with the help of Matplotlib package. So like this. As I told you, you don't have to remember any kind of like any kind of function or you don't have to write down any code here because code is also here. Suppose let me just show you all these types of plots. And again, one more point. You don't have to. It's not like that. You should be knowing about all these plots. Okay. There are some basic plots which one should be aware about. That's it. Based on that, you can go and you can plot other plots. So there are few things. So generally, this is what we also do. We talk about only the basic things and the fundamental things which are required. And obviously, once you are clear with that, based on that, you can go and you can create other plots. For example, see even Firefox, that particular logo kind of a thing you can plot here, right? Suppose let me just show it to you. If I go and if I click on this, so let me check whether it will run or not. See, below this one only we will be able to find out the code. I don't take to write a anything. Right? Let me suppose go and copy it. Suppose copy it and let me go here. Let me check which packages they are asking about. Obviously, Matplotlib package should be there. See, Matplotlib they are using, right? Let me check whether I will be able to see the graph. Now see, it has plotted the graph. Obviously, you should be knowing about the meaning of that graph. That is also necessary. That's why we will be discussing about some of the basic or fundamental plots here. You can check it, right? Now see, it has plotted. Like this, you can go with any example. Right? Even there are really good plots they have given. Here, even animations also you can do. See, these are animated graphs, right? It is also available. Again, for this one also you don't have to write down any code actually. You don't have to write down the code. See this one, the double pendulum problem. You can check that. Event handling. So this is very big. Let me see. front-end 3D example. Let me check whether this is possible. As an example, let me just write this one, 3D example. Okay, they are talking about some packages here. See, in which case you will not be able to plot it. Maybe a version is not matching, for example, some package is not there. Let me check whether I will be able to do that. I copied that code, let me paste it. Okay, so now this is showing some error. Or it is saying button unexpected keyword empty underscore. So again we'll have to check what is happening here. But yes, my point is that you can plot any type of a graph. Okay, we will upload line number 7, then DEMG. Okay, so I think it requires some file npz. See this one. So it's like a zip file actually. So it requires some data, and that data we do not have, and that's why we are not able to plot it. Okay. So yes, once you get this kind of data, you can go and import. Even you will get all these things. You just need to go and type on this. So it's a this particular official web page is really good. You have everything. Everything is given here. And basic thing, the most important thing is that you don't have to write on your code. Yeah. Let me go with the Matplotlib. Let me show you how to plot simple graph. Okay. This particular line we make use of only in Jupyter Notebook. This is called as magic command. Okay, it is only used for what? Only Jupyter Notebook, because in Jupyter Notebook sometimes you will not be able to see the graphs just because of that particular window size. You just need to fire this particular nothing. So because of that command, you will be able to see the graph in Jupyter Notebook here. Otherwise, if you are making use of some other ID or some other notebook, you don't have to fire it. Let's try to create some data and plot the graph. Okay, so let me import numpy linspace. I hope you people are aware about. So I am trying to generate some data here with the help of linspace. X is what? np.linspace 0, 5, 11. That means it's going to generate 11 numbers between 0 and 5, which are linear linspace. In that we are going to assign it to x. Similarly, y is what? Y is x to the power 2. Let me run it. Let me show you x. This is x. Let me show you y. This is y. And let's try to plot a graph between them. plt.plot. Okay, plot a graph between x or x and y. So if I go and if I try to run it, I should be able to see the graph here, something like this. Right, so this is a simple graph between x and y, which right here you can see a line or a curve, I can say something like this, depending on the value of x and y. So what we can do is we can go here, we can press shift tab, and we can see what are the other arguments which are possible for this, or maybe there are different examples which might be given here. So you can check it. R plus I can do plot xy. If you want do circle markers, if you want all those things we can try to. Let's try out this one, do and r plus. So let's see if I go here and if I try to do something like r plus. Now what is going to happen is, so you will be getting, instead of line you will be getting plus. Right? Let me go here and let me try to do do. What are you going to get? You are getting markers in blue colors. Okay? And even you can change all those shapes and sizes and text size also. So this is what, and yeah, I have run this particular thing only. So you can add labels, plt.x label, plt.y label, title and show. Plt.show is nothing but to see the output here. See, if you want to run this particular command, plt.xy, this is nothing but red color. plt.x label, y label. So what's going to happen with this? There will be a name. In this first graph, you can see that there is no name to the x axis, there is no name to the y axis. There is no title in the graph. So how you can do all these things? You can actually mention all these things with the help of these methods. X label, y label, title, and will show. You will be able to see title here, y label here, x label. And that's why that graph is actually shown. And if you want to create two graphs at the same time, you can make here something called a subplot. instead of plot, PLD dot subplot. So what's going to happen because of this? You will be able to see something like this. How it's happening? Just try to understand. See, this whole thing, whatever the place where you are able to see the complete graph, that is this particular thing. This whole thing is actually called as canvas. Right? It's a place where you are going to plot your graph, where you are going to put your graph. Right? Now this is nothing but canvas. Now how you want to divide it? How many graphs you want on this place? So I want two graphs. That means if I consider this as one row, I am dividing it into two columns. I can even divide this into two rows also, two rows, two columns. So I will get four graphs like this. Whatever we want, we can actually do. You can have 8 graphs, 16 graphs, 32 graphs, and so on. So what are we doing here? PLT dot subplot one row and two columns, and from that first column. At that place I want to plot this. See, I will just try to run the first part. So what's going to happen is now I am going to see only one part, right? But see, divide this particular canvas into one row and two columns. And in the first column, I want a graph like this. Similarly, in the second column, I want see first row, divide this particular canvas into one row and two columns. And in the second column, I want this next graph. That is the meaning of this particular column. Now see, like this, you can go and you can plot different types of graphs. So you can change this particular thing. That wherever you want a particular or respective graph wherever you want, you can actually change the point. So that's a simple thing how to make use of a subplot. Matplotlib object-oriented method maybe as per your syllabus you might not require all these things. Okay, but still I don't know whether you people are aware about object-oriented concepts or not. Generally, the people who are from computer background or IT background, they can't think about it. But yes, even if you are not aware about, do not worry. What we need to understand here is visualization, right? But using object-oriented method is one of the ways of visualizing the data. So, object-oriented method is actually a method which is used for programming, where we create the objects of certain types, and then we make use of those objects in our code. Why we do it like this? Because it saves a lot of time. It makes the thing simpler. That's the reason. For example, see this particular code. Here, what I'm doing is Matplotlib I'm making use of. So let me show it to you the output here. See here, Matplotlib is a package, right? It's a alias we are used for Matplotlib package. PLD.figure. So dot figure is a method. Now what is this FIG? FIG is the object of the type figure. Okay, so we are just creating an object. Now with the help of that object, then we are going to plot a graph. So for example, figure dot add underscore axis. Now what axis we want to add here? So like this 0.1, 0.1, 0.8, 0.8. What is this? These are actually the distance from the left, from the bottom, from the and what is the width and what is the height of the graph which you want to plot. I want to plot which graph? I want to plot this graph. X and Y and B is equal to B. And X label, Y label and title you are aware. Now what's going to happen is actually we want to plot a graph inside a graph. That's why we are making use of this kind of object oriented. See, what we want is suppose this is the first graph. Maybe something like this. This is the first graph. Okay, like this. So inside this graph, suppose maybe inside this graph I want one more graph or one more plot. That's what we are trying to do. Let me show you that. So first of all, we will try to plot first the bigger graph like this. Now, inside this, I want one more, something like this. So that's why we are doing it. See, let me explain you what is this bottom. 0.1, 0.1. This is the distance from left. 0.1 distance from bottom, width and height. So if I go and if I try to show how to plot one more graph, then you will be able to make sense about all these things. See, Now, object-oriented method, why we are doing? Because we want different objects for different plots. See, figure, png.figure. Earlier we are using only axis, now I am using axis 1 and axis 2 because I want two graphs. This is for the larger graph and this code is for the smaller graph. So if I go and if I see, code is same. Code is exactly same. Number of lines have increased just because we have two graphs instead of one. Let me show you. We got a warning, but still we should get out. Okay. Adding an axis using the same arguments as previous axis. Where we are using axis matplotlib deprecation warning. It is showing currently reusing the earlier instance in future volume. Okay, see, this is not an error actually. This is just a warning. Let me try to run. Okay, again, because we are not displaying that particular graph, right? We are not displaying. We need to display a particular graph. So what should happen is I should get this kind of a graph. But let me check it. Now it is not showing me any warning, but I am still not able to see the graph. Axis 1 and axis 2, let me check. Axis 1. Okay, it is axis 1 is created. So this is what I want actually. This one. Why we are not able to see the graph? PLT not figure right. Left is 0.1, 0.1, 0.2. Let me check this one. 0.5 is 1. Okay. This should be changed, right? So 0.2 is given, 0.54 is given, 0.3 is given, 0.8, 0.8. Still it is not coming. So the numbers which we have in these brackets, those numbers are going to decide how much distance should be there from the base, from the bottom, from the left side, from the top. So our main axis are 0.1. So I will have to increase the size 0.8. Let me make it as 0.8 means 0.5. 0.5 here. Let me make this one as 0.2. Okay, 0.2 here. 0.4. Now see the other graph. Now see, this is what I was trying out. So it was because of those values which were wrong. Now check it. We got two graphs. Smaller one is here, the bigger one is here. Now why I did so? Because those bottom, top, left, right, all the values. I want to get this one inside. So for that, what I will do is I will go and I will change this. So what I need to change is I need to change the height. So the height or the distance from the bottom, right? So you can see here in earlier case I have shown you this one. What is this? Distance from left, distance from bottom. This is width and this is height. So left, bottom, width and height. Right. So let me just go and change the values. Left, bottom, width and height. So this one is for inset axis, that means smaller graph. So what I will do is I will try to decrease the height to 0. Let's see. What I am able to see is now see the graph is at much distance. Let me go and let me try to increase the height as 0.6. Let us see. Now see, width has increased. Let me go and let me increase the height also. Suppose 0.6. Now what you will be able to see is, now see, it is coming inside that particular graph. So let me decrease this width 0.2. Okay. So if I decrease the width, it is something like this. So it is just see, manually we are doing. Okay, try to understand. I just want to say that all these things are possible with the help of Python, or specifically with the help of Matlab. 0.1 left bottom. Okay, from bottom side, how much distance you want. Suppose let me increase the distance from the bottom side. 0.4. Let me make it. Now see, it is going to come on upside. Okay. Bottom means I mean to say from the bottom how much distance you want from this particular. Okay, so you just need to go and play with all these numbers and you'll be able to see that the graph is going to come inside. Okay, like this. So if I go and try to increase 0.5, now see it is inside. So like this, actually I should take it where. So maybe I can decrease the height of that particular graph and see you will be able to see that it will be inside. To decrease the height of the graph, suppose height of the smaller graph, smaller block, and increase this, increase this one. So like this you can go. 0.1, 0.1, 0.8, 0.8. So let me make this one again. So manually I am doing, okay, try to understand. There is no hard and fast rule. So you just need to adjust all the values, all these values in such a way that a smaller value comes inside a figure. So Matplotlib will do it manually. Right? But maybe when you make use of something like Plotly or coupling, you will see that even Plotly or coupling kind of graph is going to suggest you what value should be pushed. Right? Just try to understand axis 1, axis 2, axis 2, both of them we are in the same title actually. We should have used different titles. Now axis 2 is the graph or the plot which should be inside axis 1. Suppose that's what we want. Right? So you can do those things here. So where you can make use of this kind of a visualization, you want to compare two different quantities. Right? You can make use of this thing. See, you want to compare x, y value for both types of data. You can go and you can make use of this kind of a graph. That is possible with the help of Matlab. That's what I want to say. Similarly, there is something called as subplots. Subplots also you can make use of. You can plot different types of plots. So what is this? N rows and n columns, number of rows and number of columns. So as I talked about canvas earlier, right? So I said that with the help of subplots, you can divide the canvas into number of rows and number of columns. So this is nothing but your complete canvas here. On this canvas, how many graphs you want? So suppose I want one row and two columns. So this is will be one row and this will be two columns. Like this, I can have 4 rows, 4 columns. 16 graphs I will be able to see. That's what this subplot is going to do. Okay. Again, same thing again, whatever we have seen earlier, but just by using object-oriented. So you'll be able to see these two plots at the same time. And what is this? Size, aspect ratio, and DPI. DPI is nothing but dots per inch. So you can go and you can change the size, you can change the font like this. And how to change, how to actually save the graphs. To save the graphs, we have save figure. Dot save figure as a method. You can save the graph in JPEG or PNG. That's also possible. And legends and all those things are nothing but what is called as legend. Whenever you want to visualize something, you can put the legends. Right? And that legend you can move at any position with the help of Matlab. And yes, finally, different types of lines you can plot. So as I said, you don't have to remember the code like this. Okay, everything is available on official page. So here I have shown different types of lines which are plotted with the help of Matplotlib. Just to make the sense, which code can be used for this line with all the arguments. I already told you. I am again repeating. No need to remember it. This is just ready-made things. Okay, which are available in Matplotlib. To see how much powerful it is, can actually be very helpful to do the data visualization. Okay, so maybe I'll be talking about some of the plots here. I will explain some of the plots as they have mentioned. here the types of data visualization. So just with reference to that, I will talk about that. But in this unit, our main purpose is to learn about the tool like Tableau. This is something which is going to be very helpful for the people maybe in future if you are really interested, right? But yes, as these things are already mentioned in your syllabus, I will go and I will try to complete all these things. Right? So yes, this is what I wanted to discuss today. We will stop here and we will the next session. Yeah, you can send your numbers.